Hello, and in this video we will continue creating these functions to manage the list. The last thing we did this add back function which adds an element at the back. Next one will be insert after. I call it insert after because we are inserting an element, but obviously the question is that are we going to inserting the element before that element or after the element, so I call it insert after just to be sure that we know where are we inserting it. Okay, so how does this insert after work? This is a little bit more complex, not too complex, but a bit more complex than the ones before, so I think it's a good idea to look at the picture now. Okay, so if we are inserting an element after, and for example, let's look at this example here, and let's deal with this section here. So what we have currently, we have 5, 2 and 17. Okay, let's say we want to add 33 between this 5 and 2. So we want to add 33 here. Oops. Something like this. We want to add this 33 between 5 and 2. Okay. The first thing we are doing here is that we are checking that insert after. Okay. Okay. Just checking this. Okay, sorry. I was thinking a little bit. This node here is the node we want to add after. So, for example, in this case, we want to add after this node 1. So this node here, which we are passing to this function, this should be the pointer to the node 1. Okay, so the one who is calling this function needs to pass the pointer to the node which will be the node before the new node, after we add the new node. So first we are checking that if the node which we passed here is nil, that would mean that the list is that the list is empty, because if the only case when the node can be nil is this case where there is no elements and the list is empty. That's the only situation when this can be nil, and this is what we're checking here. We're checking here that if it's nil, then we're just inserting at the front. We just inserting the element at the front, and we already have this function. This was actually the first function we created in the last video, which is able to add an element to the empty list. So we just called this function which we already have, and then we just return. Okay. So if the list was not empty before, then we go here, and first we will create just a new node, just like this one, and we will set its value whatever was passed to this function. Like in this case we want to add 33, yeah, like that, 33, and even this picture is correct actually, because the value is 33 here. So we are creating a new node with value 33. This is the function from the last video, and then we will set this new node to point to this new node. And let's see what we need to do here. Actually, I will put this, oops, I will put this into here so we can see what happens here, what we need to do here and what happens here. Okay, so first of all, this next here needs to now point to the node 2 here in this example. So this next needs to point, and node 1 knows, node 1, this node which we passed here, this node here, knows the address of this node. So node next is pointing to this node. So that's why we are saying that the new node next set to this whatever value this next have, because the next is pointing to this node. So now this next is pointing to this one after this line, and then we are saying that let's remember that this node is pointing to this node before this one. So we're saying that we are updating this next point to this node. So we say this node next set to the address of this new node, and that's why this link gets destroyed from here. Yeah, that's it. And I take out all of these. so now this function works, and we can test it. Insert after. Okay, the only problem is that we don't know the addresses of the nodes very easily at the moment. So it's better to test later this function. Okay, so let's go to the next function, which is find first. Okay, before I do that, I will copy the header of this function here, so all functions can use it. Now going back here, and let's copy the next function on the line. It's called find first. What is this find first doing? The find first function will find the first occurrence of a certain value. Like here, for example, we want to find certain value. So for example, let's call this function here. So if we call this, like, let's say we have these values, and if we call find first 2, it will find from the beginning. It starts searching from the beginning, and it will go through all the items until it finds 2, and when it finds 2, it will return the pointer to this node. It will return the pointer to this node. Obviously we have, let's say we have another 2 here, but because it starts from the beginning, it finds the first 2, so it stops here, so it's not going here. So it finds the first from the beginning. Okay, and returns the pointer to it. And obviously it returns the node pointer. So after this function we can use this insert actually, because we can for example we can find the pointer to this 2, and then we can insert after, for example, 100 here, then like this. We can call this insert after, and we can do this find 2, and then insert after, for example, 100. So this will put 100 here, because this finds the pointer to this node, and then we would like to put here the value 100 there. Okay, but let's first do this find first function and see how it works. And I will open this picture so we can see more clearly what happens here, like that. Okay, let's say that we want to find this one here, this node 2, which has value 2 here. So let's see what happens here. So this one will be 2 here in this example. Make it a little bit smaller. So this is 2. Okay, if root is nil pointer, okay, again this means that we have an empty array. If root is nil pointer, that means we have an empty list. So we are just returning nil pointer, meaning that we didn't find that. Okay, nil pointer, if this function returns nil pointer, it always means that nil return means that the element the node was not found. Yeah, so if this function returns nil, it means that it was not found. And then here we create this local temporary current pointer, node pointer, and we set it first to root. We start searching from the root. So we set this current to point to the root element, which is this node 1. And then we are doing a loop which will never stop until we stop it here. The break will stop this loop. So we will start a loop which will run until we actually there are two cases when what can happen here. The first is that we find the node, or we don't find the node, but we will reach the end of the list, which is this one. So when we reach this nil, the node which has next is nil, then we stop this loop also. Okay, so inside this loop we are saying that if current value is the value which we are searching for, then return the current node. Okay. And if this didn't happen, then it goes here and it says that the current it's checking the other condition, that if the current next is nil, meaning that it's the last element in the list, then we are breaking the loop and we are returning nil pointer, meaning that we did not find this value. And lastly, if no exit condition happened, then lastly we are just updating this current to go to the next node. Okay, let's see here from the picture using this example number 2. So if we are searching value 2, what will happen here is that current set to root, then current value, which is this number 5 here, if 5 is true, well, it's not true, so it goes here. It's checking that if current next is nil pointer, well, this next is not nil pointer, it's the address of this second, so this is false as well. So it goes to the else block and it sets current pointing to the next, which is now node 2. So now current is pointing to the node 2. Okay, and let's see what happens then. Then it says that if current value is this 2 here, okay, and because this was 2, now this is true now this time. So it goes here and it returns the pointer to the current, and current is pointing to the node 2 now. So it returns node 2. Okay. And that's it for this function. And let's use this function now, because we have this insert after. So let's use this function to insert after a certain node. So now we have 1 to 17. let's insert, I'll take out this one, and first of all let's find the node which has the value 2, which is the middle one here. So we will need to save this node pointer like this. So this find first 2 will return the corresponding node. So we will save the pointer of that node, and after that we can call this insert after, which takes 2 parameters. The first is the node, okay, node, and the second one is the value which we want to add. Okay, we want, let's say, add 111. So this will add 111 after this 2 node, and let's print to see it works. Where is it? Print list. So print list after all of this, and let's compile. Okay, succeeded. And there we go. So we have this 1, so it was 1 to 17, and then 111 is added after this 2 element correctly. Okay, so it seems to work. We can do another try. Let's add this 111 after 17, which would be 17 is the last item. So let's, and that one also seems to work. It goes to the last. Yeah, so it works. So next function will be, there is no next function. Okay, but just to show how easy this is now to continue with this one, I will create Tempo Vista just on the fly, Primo Vista, or how do they say. I will create a new function just like this. Let's see how well I can do it without preparations. So let's create a function which will calculate the number of the items in the list. Let's call it, so it returns integer, and let's call it size, number, list elements, how do we call that, list size, list size. Okay, let's call it list size. We can change the name later on if it's not good. Okay, list size. So it will definitely loop the whole list again. We have this loop already somewhere. Where it is again? I think it's this one. So this is the loop. Find last node. That loops the whole list, isn't it? So we will put this code here. So we will start from the root. So current is pointing to the root node, and then we will loop this until we find the last one. And as we are doing this loop, we are increasing the counter by 1. We need to create a counter here. Let's call it size counter, and it starts from 0. Well, in C++ we do like this. We initialize to 0. In C you would just set like this, for example like this. Let's do C++ now. Okay, so, and here we will increase the counter by 1. Okay, and then we just return the counter. So this should definitely, it should be this easy. So let's just print this now, this counter here, just to see out size, and then call this function and end line. And let's see if I was able to do it without mistakes. and there you go, size 3. So that's how easy it is to add new functionalities now just like that. And yeah, that's for now. I'm not sure if I'm gonna add more functionalities, but you know, there are other functions we need here. We obviously need the functions delete. We also might need the function remove all, which would remove all functions, all nodes, and we would like to maybe delete at the position and things like that. And so let's see if I get excited and I will create more of them, but it should be easy to add those. Another thing we have here is that now this root is here as a global variable. So the one problem we have at the moment here is that we have only one list here, unfortunately. We have only one list here. Let's say that, so this main function here is dealing only with one list. It's only one list here because there is only one root. There's only one root here, and all these functions are using the same root. So we have only one list. What I mean is that we have this list here, but let's say that we want to have another list here with different items. Let's say 3, 3, 5, 5, 6, 8. So this is a list 1, and this is a list 2. They are separate lists, independent lists. So this code at the moment can't do that. It can only handle one list. So I'm planning to create a new lesson, new video next. But this is actually very easy to do now. It's very easy to do now, so it should not take a long time to do, because the only thing we need to here really do is that we need to create here one more variable, maybe a struct variable which contains the root, and then just use that root here. So I'm planning to do that one maybe next. Okay, thank you for watching this video. Bye for now.